Good morning, everyone. My name is Dave Ward. I'm usually up here and talking about how to build routers and what's coming next in router design or in protocol design. But instead, I decided to take an opportunity today to talk about a general trend that's going on in networking, and it's really about programmable networking. And there's a lot of shiny objects that can really distract you or potentially even confuse you when trying to understand what's going on with all the different mechanisms that are available for programmable networking and the information that's available in the network. Now, before I get into this talk, following Kevin's talk, being the slow vendor up here, I also do want to mention that these large interfaces are available from vendors, and in fact, perhaps operators could also increase their uptake of the new technology, but that was basically required. I said that after Kevin told me I was too slow. All right, so let's jump into this talk. So the talk is named Programmable Networking is Safe for Work, and that's really because there is a very large trend, as I just mentioned, in a number of different interfaces that are available for application developers to actually fundamentally get information from your network as well as program devices on the network. To keep it very simple and to start off this conversation, building up to where I want to get to with respect to technology, application developers are wholly interested in the experience they can provide for their particular customers. This is obvious. Whether it's high-definition video or it's location-based services for social networking or whatever the case might be, their goal is to get the best experience possible out of the internet. And clearly, as network operators, your goal is to connect everyone to everything and everyone to everyone else, of course. But the issue that we fundamentally have is that application developers, and here's the fundamental assumption which we can discuss a little bit later, is the fundamental assumption is that application developers today don't have a good understanding of the weather report of the network. They don't know where things are located necessarily. They don't know what the utilization of the network is. They don't know what access link speed might be available to the particular other user or subscriber, or whatever the case might be that they want to talk to. And so this fundamental wall between what the network can give to application developers and what the application developers need from the internet is what needs to change. The next assumption that I'm going to make, and this is perhaps one of these visionary Keynote-y type things, is that the application developer who actually is the first to program either devices on the internet to create specific paths for the service they want to offer, or to be able to get information out of the internet like a weather report of utilization, is going to be the one that holds the next lottery ticket. And what I mean by this, or the next winning lottery ticket in particular, and what I mean by this is that clearly when taking a look at applications that are available on the iPhone or whatever the case is, folks are attempting to pick up that winning lottery ticket by just pushing more and more and more applications out there. And differentiation of these applications is generally based upon the experience and information that can be delivered. And so, leading up to this, the goal is really to describe what's coming down the pike and what's really different. So applications today, when taking a look at the network, are really just guessing. They're attempting to divine what's going on the network. They're blindly probing and trying to ferret out this information by using gaming ping stats, or there's proprietary codecs, or there's control channels for variable bitrate video, or they're using whois type technology to find which autonomous system or which provider has a particular bit of data that's not suing them at one particular period of time. Really, there's no fundamental interaction to get this data out of the internet to find either the best location for content or the best way to deliver this service. I can't tell you how much it drives me crazy that, for example, proprietary control channels attempting to scavenge bandwidth out of the network are being proliferated left, right, and center when in fact the network has the information directly. And if they just asked, and if we just had the ability to give them some information, the switch and understanding when HD is available versus SD, when to scavenge for a certain amount of bandwidth would be possible. This would be a much more efficient way to do it than a very aggressive algorithm of everyone attempting to compete with each other for this particular bit of bandwidth that could be available. Now, on the converse side, as networking professionals, we're really spending a whole lot of money and a whole lot of time and a whole lot of effort trying to figure out what's going on the internet itself. There's deep packet inspections and stateful flow foo-bars and all sorts of other different things that are being implemented in the network, really just to try and find application signatures such that interesting things like application-based billing or just understanding if there's some good behavior or bad behavior going on the network. In addition to this, whether they're IP data records or whatever the case is, for an attempt to find out when a user has gone above a particular bandwidth threshold for any particular purpose is about the current state of the art. We actually could know more information if applications would simply tell the network. So on both sides of this conversation, whether they're applications trying to divine something about the network or the internet trying to figure out what's flowing across the network, they're very expensive as well as cumbersome behaviors in trying to figure this out. So really what I'm leading up to is that these four different actors need to come together in a coordinated fashion, whether it's the application, where it needs to know, it would like to know, I should say, the end device capabilities, proximity to a particular bit of content, etc. Whether content, which is located somewhere in the network, can either be placed somewhere else, or we can find out where to select it based upon analytics of the server, and we'll get into examples of this in a second. We have the end user who knows what they're looking for, and we have the network which has fundamental information of understanding where is an end user, where is the content, what is the application. If we could interact amongst these four actors, we could probably do something better. And there's going to be a number of talks about some of the fundamental technologies over the next couple of days on pulling these together and use cases that can arise out of this. So let's move this a little bit forward and talk about why networks and applications need to work together. So really, what I'm trying to say is that it's not just programming the network. It's not just an application programming a device with a specific service profile or programming some VLAN tag. There's actual bidirectional information that's possible for the network to give to applications. And so when I describe programmable networking, it is this two-way communication. So as I mentioned already, if the application has the ability to inform the network, and the network can give fundamental intrinsic information back to the application, we then can begin to talk about how we can affect and bias traffic steering on the network to either preserve fundamental bandwidth that's available in the core, or in particular, to increase the experience that's available. And so towards this end, what I'd like to describe is that there's a number of touch points available in the network that we traditionally hadn't considered to be as programmatic points. And these can come from either on BNGs or BRASs for subscriber termination or user termination. Today, the state of the art is effectively using radius, diameter, COPS, packet cable, whatever the case might be, to program a subscriber's profile. And no doubt, I'd say triple play services, voice, video, and high-speed internet, these are well established and have been deployed to a great deal across the internet. But what we've gotten to the point is now is that the high-speed internet class, where the over-the-top traffic is coming in, whether it's peer-to-peer downloads or whatever the case might be, this class of bandwidth is the class that's being scavenged and aggressively trying to be scavenged amongst a variety of different applications. And we know that the time and ability to turn radius, diameter, or COPS profiles to program these subscriber profiles, these delays are far too long. The current mind share or groupthink of what's a cool application today or what's a cool bit of download or whatever the case might be, these things are fast and fleeting. They're completely ephemeral. Now, towards that end, if we had the ability to program this high-speed internet class from different applications that are part of a subscriber's profile, we'd have the ability to deliver better experience. Now, as you've been reading, hopefully, the other touch points or other points where we can program on the internet, these are all different, what I would call perimeters of the internet. These are all different locations where you actually can derive where a subscriber or user lands on the internet itself. They can be VPN gateways, they can be trying to go after a particular bit of content. Once you have awareness of what an application or subscriber is trying to do on the network, you can build specific profiles at each of these points. These are all of the programmatic points on the internet, or many classes of them, that we need to be interested in when building out the entire portfolio of different service profiles that are possible. And we'll come back and we'll touch on some of these with some actual use cases. So what's possible? So applications or services can be made better by getting a weather report of what's going on the internet. Proximity to content, proximity to a server are some very, very easy ones to understand. In addition, by just understanding the access link that your friends or family are attached to, you understand the type of quality of service you can get out of this. And at the same time, there's been quite a bit of conversation recently about networks being made better by information from applications. And really here, what's trying to be described is you do have the ability to optimize bandwidth or resource reservation. You can spin up new specific service topologies very, very rapidly through some of these interfaces. So let's get into the point of where we talk about how they actually work together. And what's key to this conversation, just pausing for a second, is that there are a number of very high-level conversations that are going on about different programming points of the internet. And all of them appear potentially to be solving a large number of problems, and they all appear to be solving all problems on the planet. Whether it's virtualizing data centers, whether it's virtualizing data centers, whether it's building the service profiles for subscribers, whether it's populating content caches. What's interesting about all of them is that they all are independent ways to program the internet, all attempting to duplicate connectivity between two different points. The key to remember when looking at these different technologies is that we aren't necessarily going to reinvent the internet and all of the protocols with any new particular way of programming the internet or any new technology. The key is how these technologies are going to integrate directly with the internet and the networks that we have deployed. Anyone who's been around for a while understands that if we go back to a world where we're again signaling permanent virtual circuits a la X25 ATM frame relay across all the network, we're going to have a huge control state problem. And in fact, really what we're trying to do is find a way to take advantages of programming specific devices and take advantages of giving applications and services information from the network in conjunction with what's deployed. So really we're talking about what's augmenting what already exists. And this will be some of the use cases that I'm going to bring up in just a second. So the technology that's really emerging is multifold. And I'll bring it into a layered perspective in just a second. So again, today what we're trying to convert from is where we're intuiting information from the network on application side or from the networking point of view. Again, we have geo-coordinates, proprietary control protocols, and the network is using DPI's net flows, IP data records, and then we're trying to get to a point where we're communicating this information. Now the challenge of trying to do this is that there's a zillion different stacks out there, which are again getting a lot of conversational highlights in the trade regs. Cloud stacks, open stacks, whatever the case might be. Open flows, which Rob Sherwood will talk about over the next couple of days. But also there's been a trend, and it may not have been visible to understand that there was some architectural thought behind this, but there's been a trend over the last 10 years for communicating this information within the protocols that we currently have designed, such that we can extend APIs and extend information that's being transmitted via these protocols in a variety of different categories. So first is path computation element. Brief bit of history. Path computation element was originally built or constructed for inter-autonomous system traffic engineering end-to-end path setup. That sounds fine. We didn't really have a very easy ways of doing that. But what's interesting is that once you have a server that you can program to that can communicate with routers to set up paths between endpoints, we have reinvented soft PVCs. And I bring this up because I have a long career of reinventing things many, many times. And in fact, what I want to highlight in all of these cases is that by reusing technology that we know and understand very, very well, we can use these to obviously benefit not only application developers and the services on the internet, but the quality of experience on the internet itself. So we'll start with path computation element, and I'll build these up in a couple slides. The next is GenApp, and you might say, well, what the hell is GenApp? I haven't even heard of this thing. So what generic application extensions to the IGPs are, is the ability to pass application information or application server information within an interior gateway protocol like ISIS or OSPF. And you say, oh, for the love of God, the last thing we need to do is overload these routing protocols with more crap. And thanks, Dave, for reinventing that one. Well, there's good news. I didn't necessarily invent it or it wasn't invented to necessarily be transmitted directly with the routing information. We learned some lessons and we realized that in some cases we need to disseminate information via flooding protocol. OSPF and ISIS are very good at disseminating information. But we don't want this to be passed with the routing information. We know that we want routing to converge faster than we necessarily want application data to be sent. So there's been, over the number of years, there's been inventions of multi-instance of these interior gateway protocols, and now there's the ability to pass generic application information. So now if you wanted to, for example, say that you have a NAT, a firewall, or some kind, or a DPI service at a particular location, you can pass this without fundamentally decreasing fundamentally increasing router convergence or decreasing performance on the internet. Moving through some of these others that we'll talk about, and I'll talk about in a little bit more detail, which is ALTO, the application layer traffic optimization protocol. We'll hold this for a second, but really the point is that over the last couple of years, folks have been trying to build protocols that we can begin to signal and communicate the best location via proximity of a user or application to that particular service. And then the last one, which is just recently emerging, is BGP with traffic engineering extensions. And once again, I recommend you to remain calm when I talk about putting more information into BGP, because that generally gets people upset. Again, we have realized that it's possible to pass information in BGP without using the same peering session that's passing routing information. BGP can also be multi-instance. Now also, the next thing that generally gets people upset is we're talking about traffic engineering in BGP, and they say, for the love of God, we don't need to be able to signal traffic engineered paths with BGP. Well, that's not what this is about. This is merely about passing interior gateway topology information and traffic engineering information in a BGP container across a normal operational control plane like route reflection servers, such that you have full view of a piece of a POP or the entire topology available via one control mechanism. And I say this because, again, if you step back and take a look at, survey the protocols of how you would get topology information, say, into this ALTO protocol, or how you'd get topology information in general, we've spent a lot of time arguing at various standards bodies of it must be ISIS, it must be OSPF, it must be BGP, it must be any of these things. These arguments are a complete waste of all of our time. And I say they're a complete waste of all of our time because we don't have the capacity as an industry to be able to have 42 different ways of doing the same thing. And again, stepping back, most networks are built out of a control or management functionality in which route reflection servers actually exist. And therefore, maintaining the common protocol that's being used with respect to manageability and putting this information into BGP made perfect sense. Next, and the last piece, and I'm still introducing the subject, is that we're putting yet more information in BGP. And again, hold your coffee. Really the situation when we put in CDN information into BGP, and this can be both the users that are possible to be reached in a particular geographic area, and I said geographic very specifically in this case, the users that are reachable in a geographic area, or the content that's reachable via a particular peering point. These are new extensions that you're going to see rise. So tying this all back to what we want to be able to do with programmable networks, we have fundamental protocol building blocks to pass information up to applications via common pathways using our protocols, yet not affecting routing. And we have well-known perimeter points at which we can actually now program service profiles, program paths across the network, and fundamentally bias the service and experience we're going to get across the network. The key is how to do this without breaking the system. And I know I asked you to hold your coffee several times already this morning, but really my story that I'm trying to tell you today is that we in fact can do this without breaking the entire internet and causing our routing peering sessions to go down and causing fundamental crashing left, right, and center if we're worried about the fragility of our particular protocols. So what I've built up from the bottom in this particular slide are the network APIs. This is what me, your vendor, is going to be building out of the into the system. And really they come from fundamental constructs of what's available in routing protocols, as well as fundamental constructs of programmatic interfaces that currently exist into these perimeter points. So I already alluded to the fact that one of the perimeter points of subscriber termination is using radius and diameter. Radius and diameter, just summarizing quickly, has inside the device been abstracted to a single common communication channel between the control plane and the forwarding plane of the router. This has basically been done ubiquitously across all vendors. That being said, it's actually very straightforward for a particular routing vendor to take a common API, a common abstraction of what that internal protocol looks like and turn it into an API versus getting locked into radius and diameter. Same thing goes for these other bits of technology. Now what's interesting about this is frequently you can get confused to think that an application developer is going to be writing directly to these APIs that are on the router themselves, and that isn't the story that I want to tell. Because most application developers, and think about the folks who are out there coding up Farmville or Mob Wars or some other stuff that I don't understand why anybody would want to do, but nonetheless, these folks are thinking about programming and thinking about delivering experience fundamentally differently than delivering it on the network. We don't necessarily want the guy who wrote Farmville to write directly and use a BGP interface. We know that already, right? We don't want, I don't need to continue. What they're going to see instead are orchestration platforms that are on top of these networking APIs. Our goal as networking operators and professionals is to get this information out and available onto these orchestration platforms that the application developer who's building the next video service that wants to run over HD using variable bitrate video, or the next MLB.com, and this isn't a pitch for them, or the next Farmville on steroids, they are going to be right into that orchestration platform. They're going to be coming to you and saying, I would like to run this over your network, and you would like to have business with them to deliver it with the best experience possible. So they're going to see these orchestration platforms. They're going to see the weather report and proximity information on the network via real-time topology information and real-time utilization information. Towards this end, again, we've talked about proximity information, we've talked about taking TE information. Just a quick digression, with respect to traffic engineering information, this may be a shock, but we've reached the point where there are new attributes that are going to be passed that include things like delay. Now, I've been around for a little bit, and I understand the issues of doing delay-based routing with respect to what happened in ARPANET many, many years ago. But the mere fact that we are not passing delay constant associated with our paths, not necessarily using it for active or even protection path backup, but the fact that we aren't using it at all in our calculations, the time has come where we need to be able to talk about this again, and these variables need to come back. So delay, variance, loss on a path, utilization on a path, these are things that have been a long time coming. I realize that it's been over 20 years or even over 25 years since the last time that there were attempts to use delay-based routing were on the internet. But we do not need to take the same approach and technique that was taken 25 years ago. We do need these variables available to us as network operators as well as to application developers to increase or improve the experience on the internet. So this real-time topologic information and real-time weather report information is now fundamentally available coming out of the network. But again, let's make sure the Farmville guys who are coding this stuff up, those frat boys, are only coding to the orchestration platform and not touching the routers themselves. We've already talked about steering traffic and building soft PVCs up through path computation element. And Rob will be talking about OpenFlow in a little bit, but in sum, just quickly, OpenFlow is a technology in which, and it's the only technology in which you have the ability to program with high performance, real-time, ephemeral classifiers that are not held in the router's configuration file. They're coming from application space and being jammed directly into the forwarding plane. So you can think of this as a traffic selection mechanism, a programmatic traffic selection mechanism. It's a current shiny object that's being discussed quite a bit, but at the same point, it has high utility for a particular bit of functionality that isn't otherwise available. And I've already reached on these new touch points. So let me build up just a little bit further on these protocols and really what we're trying to accomplish with them. So when we talk about what we want Alto for, and it's again application layer traffic optimization, from an application space, what you're asking the network is, where is it located on the internet? And how far is it from me? And you're going to see, I'll walk you through an example in just a second. That's what we're fundamentally trying to accomplish from application space. The next piece with respect to path computation and path computation element, building soft PVCs, is basically how do I get from where I am to where it is? And how can I dynamically program and using the current signaling control and signaling mechanisms on the internet to get me there? We've got policy enforcement, and as I mentioned, OpenFlow is excellent at programming these classifiers, and there's other mechanisms as well. And then the last one is just service location, which is basically object-based routing, and this is part of BGP CDN work. These are the fundamental building blocks. Where is it on the internet? Where's my object? How do I get there and make sure only my traffic gets there such that I don't have to compete against everybody else with this particular service offering? As 4 fundamental building blocks, this is really what's underneath it all, in understanding how these different pieces come together. Now, what the application developer is going to see are these orchestration and development platforms. And I've segmented into these 4 different pieces. Traditional IT, which is OSS, BSS stuff, and again, there's a number of different ways to perform device and subscriber management, and there's entire industries, and have been for decades, in trying to build up these billing and subscriber profiles, and again, turning this into billing information. There's network function specific pieces, and this is where there's lots and lots of shiny objects for us to get distracted and confused over when it comes from either service level monitoring, over the top virtualization, path management, unified communication. There's umpteen different elements or programmatic interfaces that are being currently espoused out there that can solve all the problems. Just understand what they're trying to accomplish, and they're trying to accomplish network function specific tasks. The next, of course, would be service specific, and I segment this out because here really it's more related to social networking and location ID information, and what you can do with location information when building up a particular service, whether it's social media, whatever the case is, and we'll get to that in a second. And then the last one is a provider-based development platform. So looking at these 4, OSS, BSS, network functions, service functions, and provider-based platforms are the main categories that I'll use in my use cases. So these provider-based platforms, what becomes very, very interesting about these, and being from California, on the peninsula, south of San Francisco, these are several of the operators that currently have application innovation centers being built or currently working on the peninsula themselves. Now, what's interesting about this, and the reason why these large telcos and MSOs are doing this, is kind of obvious. They want to capture some of this iTunes and application frenzy that's out there. It appears to be just giant, bagfuls of cash that are available. There are, and that's good, and that's a perfectly fine reason to go after the business. But what I've tried to build up into this conversation is that these telcos and MSOs and every network actually has information that will fundamentally make these applications better than a simple over-the-top based service. And if if the folks coding to Farmville switch from coding to, say, a Facebook platform, and this is nothing against Facebook, so remain calm again, and switch over to these development platforms, the point I'm trying to make is that they automatically reach half of the world's population and 2/3 of the world's GDP. There is a whole lot of potential here for programmatic networks, and there's a whole lot of potential for these applications to really hit it big if they can provide a better service than was done just straight over the top, competing in an aggressive scavenging mechanism as is otherwise done. So let me give you a couple of examples, and we'll walk through some of these use cases. They're pretty straightforward, meaning that I think we've heard about them quite a bit. Whether it's content and service routing, whether it's locating the best content or populating caches, map reduce stuff, which is done to great scale by the search companies, network operations, whether it's VM mobility, storage, I/O, etc., cloud bursting. So let's walk through a few of these. But before we hit these direct examples, I'm going to tie together this technology such that you can understand how it's being used in these use cases. And tying together this technology is a combination of a few of these programmatic techniques. So what I'm trying to describe is that if I know that Dave and I want to communicate, and I'm in California and he's in Oregon, and we want to build a specific communication channel, I need to know where Dave is in Oregon, and I want to build a particular path to get there, and let's say I'm going to use traffic engineering. But what's interesting, of course, is that once I've built that traffic engineering path, any of my data or any of the data around me could potentially use that path to get to Dave. But if I program classifiers in front of that such that my specific service or my specific service that I want to work out with Dave is all that will traverse this particular tunnel, and we've reserved a certain amount of bandwidth, we now have, instead of having a traffic engineered path, coined as a service engineered path. And really what this comes down to is my application that's building the service can set up the soft PVC or set up the path between Dave and I, can program the specific admit deny criteria, and my service has a certain amount of reserved bandwidth, a certain experience that I'm going to have between Dave and myself. So by building up a couple of these common building blocks, or using a couple of these common building blocks, we can actually easily create something new and better than what we had in the past. So towards this end, one example is what can you do with this technology? You can basically attempt to build pools of service applications or service appliances. Now today, taking a look at edge routers, I'd say the average is somewhere between 13 and 20 different service appliances that currently surround subscriber terminating edge routers. These are physically bound via orange or yellow cables directly to that single edge router. What's interesting is that they cannot be used easily or cannot be used at all by other edge routers. So what this technology can do, again, when you classify specific traffic and have the ability to do service backhaul, if you want to think of it that way, is you can now take these service appliances and pool them together in a data center or in a POP and have them just be seen as increments of bandwidth, scale, or performance. So that now these service appliances can be shared amongst multiple edge routers. And these can be distributed, or they clearly can be pooled all the way back into a centralized data center. There's no topologic restriction. And it fits directly into that analogy of doing service backhaul, because again, you've classified only the specific traffic. Again, it doesn't have to be all of Dave's traffic. It could just be his port 80 traffic. That's backhauled to a scrubber to understand why he's out of bounds on his bandwidth threshold, or whatever your example might be. This also is an extremely powerful way to build service-specific topologies across a network. Setting up TE paths to set up service topologies, nothing new, bread and butter. What is relatively new is that in combination with the ability to program ephemeral classifiers into the forwarding plane, I can dynamically build the profiles and modify the traffic or flows that are going across those specific profiles. It's not bound to some multi-week, multi-month, multi-year deployment of some particular new service. Instead, this can be extremely rapid. I mentioned also for content request routing, and I'll build this up through a really clear example, hopefully. So really what we're trying to do is have a user query the network, where is the best place to get my content? And that's what this Alto server is actually building, or is actually based upon. It can give network proximity. It can do a reverse SPF to a particular user to understand where they're located on the network. We can build in network server load congestion, etc. And for that content routing request, you can get the best answer to deliver the best experience. So let me show you how this basically works. Assume that there's 3 users, whatever the case might be, New York, London, and Paris, and there's 3 data centers. Chicago, London, and Amsterdam. The user is simply saying, or application saying, where do I go get this data? And they're going to go use DNS or a web plugin. That web plugin or behind the DNS actually would be this application layer traffic optimization server that says, where are you? Where's the content? Let's use the shortest path to get there. We'll add in a little bit on network utilization as well. In combination, because the service or application is going to a particular media center or media server, those media servers can reply back saying, here's my load, here's the number of connections I have, here's the amount of bandwidth that I have available to pump out. And the union of these two pieces of data, the network information, proximity information and weather report, as well as the media server load, can be constructed and built into the best answer. And so you're going to get per site, whether you're New York, London, or Paris, per site, based upon your view of the network and where you're located, the best media server to go to. And in this particular case, New York is supposed to go to Chicago. Now, being from Minneapolis, Chicago is rarely the right answer, but in this example it is. Somebody's listening, good. Okay, so towards this end, I'm just going to skip over and basically show that media servers can use thresholds like load and number of connections to divert traffic in real time. And really what that means is that Alto will direct the traffic the best based upon network proximity, up-down status and congestion, and the media server will override with respect to how the load is on the media server. The next example, which is again relatively straightforward, in particular if you have a video service and you need to either deliver that content to caches or distribute data, or the other easy case to understand is a data center backup, when you have to move 10 terabytes of data long distance over the WAN, and you have a necessarily constrained WAN bandwidth where you can't place 10 terabytes at any time of the day or at any particular location. You want to calendar that bandwidth onto the network based upon priority. So again, service placement, data center backup, and cloud orchestration. So the first thing we want to do is schedule and reserve that path. And we're going to use this orchestration layer, and we can demonstrate that, yeah, you can submit your job that I want to move 10 terabytes between New York and Reykjavik, and I need to do this at medium priority, and I want to do this between midnight and 6 a.m. European time, or whatever the case might be. And the key is, we don't want to push all of the network state up into the application. We don't want the application to have to derive what the topology is, or understanding how to set up a path, or work with other multiple NMS, EMS systems to be able to do this, and instead use the pieces that are available, which is that, what's the real-time topology understanding, which is go query Alto server to say, where are these particular locations on the network, and what does the topology look like between these 2 points? We want to be able to set up this path, again, only between 12 and 6, so we'll use a soft PVC mechanism. And the application will program the two endpoints and say, build me a path. Off we go. We're going to then make sure that only specific data is traversing that path, and we'll use OpenFlow to be able to program that. The application developer actually would not see any of that. They would just say, I want to send this traffic between these 2 points, and a priority. And you as an operator would be the one who would be managing those particular priorities, knowing that these APIs are underneath. Now, also towards this end, the key is that as an operator, you want to be able to affect the algorithm that's used to place this bandwidth. It could be a water filling algorithm where it's just, put it on there where it fits, and the other one, of course, could be bin packing, which is I want the ability to push traffic away from these particular paths to be able to load it in a loop-free path that meets my SLA or my delay guarantees for this particular backup. That's the intersection of the two. You've got the network APIs that are being exposed to this development platform. The application developer is doing what they do, which is just, look, I need to back up my data. I don't want to worry about this topology stuff. You meet at the two, and you can control how that bandwidth is going to be placed on the network. Cloud bursting is the next really popular topic, really popular use case in this particular part of the industry. And really what the whole goal of cloud bursting is that I'm a private enterprise, I need some more compute or storage. I don't have it available in my data center. I think I'm going to go grab some out of EC2 or Azure or whatever the case is real quickly, and I'm going to finish up my computation and off I go. This is the most common use case used by the OpenFlow folks, and it works really, really well. And really what it is how to extend an L2 domain from my data center to a remote data center at a particular point in time. And I'll save some more for Rob. The last example I want to give is social networking. And cheekily I call it today's wheel of misfortune, because in social networking and location ID, which is a massive topic going on in trade rags right now, is all the services you can do on location ID information. And what's interesting is that there's a number of categories that end up trying to use this information, from gaming through social stuff, advertising, of course, and commerce, people trying to inject coupons onto your mobile phone and all the rest of it. But what's really interesting to me is that there's an untapped mine of information that's in the network that folks aren't using to be able to build better location-based services. Really, really straightforward stuff. Am I on a laptop at NANOG, or am I on my mobile phone walking around about town? If you knew the difference between the access technology of who you want to communicate with, you could deliver a better service and better experience. This giving information about the access link out of the network is bread and butter of what we know and what we can do. And then the rest of these other bits of information that perhaps you're reading. What are the capabilities of that device and network? What's the proximity to some cache or server that this service may be using as a third party? These types of things, again, are bread and butter of what we can understand out of the network. As well as bandwidth and billing profiles. Am I close to my limit? Do I want to build that information into the service? As a network operator, by giving this information available to these application platforms, you can fundamentally bias how they're going to be built onto your network. If we continue down the path that we are today, which is that there's no information coming out of the network, then there's absolutely no way that you will give them the ability to affect their experience, or you will have the ability to control what that application is doing on the network itself. What I find really interesting is that the three fundamental architectures that are being used for location-based services, which is either you're above the topology like a looped or Foursquare type service, or you're visualizing the topology like NavTech, or you're below the topology and trying to build location-based services into an operating system like Android or iOS. These are relatively simplistic and very, very basic understandings of the topology. All you have the ability to do is say, I'm here. And you can do this through active broadcast, and an active broadcast of where you are is by checking in. And yeah, it's kind of fun to know who's in a restaurant. But again, these coordinates, these GSM coordinates, give you information of how to drive to your buddy who's in the nearby restaurant. It doesn't give you any information about the quality of service or experience that you could have with them. I don't fundamentally understand why navigational coordinates are a fundamental interest to location-based ID, except the fact it's the only information about the topology that an operating system on a mobile phone actually has access to. And so if we increase the information that that operating system had, then I believe that we could build a much, much more interesting and rich service delivery experience. So towards that end, the information that's bread and butter that exists in the network today that's possible to be given out is, you're here. You have this access technology, you have this capability, the network has this utilization associated with it, and here's that service profile. And these are the things around you. It's content, resources, places, people, and their capabilities as well. And so I think we can get beyond the basic fundamentals of how geolocation-based services are being done, and we can improve upon it. So what did I just say? Basically, there is an architecture of what's being built and what's being designed of information that's coming out of the topology and the network APIs that are emerging out of our routers, switches, and routing protocols, etc. These are being plugged into development platforms. Large PTTs, MSOs are all over this, as we already discussed. And there's a lot to be gained, a lot of people that can be reached, and a lot of potential revenue that can be garnered. Also, what's important is that this is a critical period in which it's selected how this information is going to get out and how fast it's going to get out. It's very, very challenging to overcome the over-the-top issues that may exist with respect to bandwidth scavenging on the network. This is one of those techniques, which is to realize that the network can give out information that an application can use to make it better, and an application that you can control can program the network to deliver a higher quality service. So towards that end, I'll finish at this point with just a few minutes left if there's any questions, but thank you very much. Any questions? Any questions about 100 gig interfaces? There you go. I'll repeat if that helps.
Hello?
Go ahead. You're on.
Valencius, Georgia Tech. Thank you for your talk. Very interesting. I had a question. So you covered a lot of technology, but could you comment more on money flows? Who would pay whom, and let's say Zynga or Farmville, would they pay for this? And when they have a choice of just scavenging the bandwidth?
So money flows. Realize I'm a vendor, so I already have a perspective on which way the money flows. But kidding aside, I would imagine that Zynga would be wanting to get into collaboration, and this is my fundamental assumption, that Zynga would want to get into collaboration with network operators or autonomous system service providers that are willing to play this game. If they can deliver a better service over a particular network, then they would be interested in having money flow in that direction. And if users are willing to have a better experience over one particular network or another, money generally would follow that as well. That's the fundamental assumption. Again, I am not an economist. I just play one at this podium.
Hi, Patrick Gilmore from Akamai Technologies. So 100 gig interfaces, when are they going to be less than 10 by 10 gig interfaces? Less money.
Oh, less money.
Because from a network operator standpoint, the difference between a 100 gig interface and 10 gig interfaces is a wiring problem, unless it costs too much money, right? And so you want us to use 100 gig, why not make it worth our while? If you were selling 10 gigs at 12 times a gig E, how many people would be using them, or how many people would have been using them in the past?
So I think we're going to have very nice weather in Philadelphia this week. It should be in the 80s or so. So the pricing question is very different from an engineering perspective. So
okay.
I can't help but
going back to the most excellent talk, actually, thank you very much. It was useful and packed with information, which is not always common. So thank you for that. But when I'm watching this, while I'm thinking this could be really good, a few things obviously pop out. The first is this very clearly rings gigantic alarm bells about things like network neutrality. And the answer to your last question actually even highlighted that. So you're going to have services that can pay for better performance, or you're going to have network operators who also happen to be, I don't know, for instance, MSOs or say telcos that run their own cable TV service, and their streaming, for instance, could be prioritized over somebody else's streaming. What happens when Netflix is competing with AT&T Uverse and one of them is picked in this path? You have a decision matrix there that is opaque to anybody outside of the network, and then the network itself is deciding whether their information is prioritized. Now I realize that we already have that problem today, but this, as they say, pumps it up a notch. So wondering just how far are you going to be able to, as the vendor here, running the server in the middle, how far are you going to be able to make information public that the network's going to feel, maybe not public, but transparent to the users of it, that the network's not going to feel is giving too much information about their own infrastructure?
Oh, that's a very good question. So it's actually loaded with a whole bunch of carefully laid landmines there. So,
pretty much.
So with respect to what can be done with this technology, I think first and foremost, if we want to help address, let's say, some of Kevin's issues that he talked about earlier with respect to the amount of bandwidth growing on his network, let's say he's going to deploy caches. It generally seems to be something that folks do. And now there's content available on a particular cache in a particular area that isn't the one that you're reaching at. If he had the ability to apply policy of where a request for content is going to go on a particular cache, and it either goes to the closest one, or then it goes to the one that meets the SLA, meaning that it's actually not overly loaded, et cetera. These are some fundamental ways that it can be moved forward. I'm completely sidestepping the net neutrality conversation, as you might notice, but really my point is that we can start earlier without jumping directly into an FCC legal situation by actually improving the network without stepping in that landmine. Is there an absolute possibility that specific services can be built with higher quality than others and it can be biased? Absolutely, that can be done today. These are just more flexible tools to be able to do that as well for services that are being provided by a particular provider at this point. I mean, I'm not going to skirt the issue of net neutrality, but there isn't much I can say about it at this particular point, given FCC's position.
Pretty good answer. Thanks.
Hi, Jeff Sachs from Blue Ridge Internetworks. You said that in the slide nearly at the end, you showed that network operators could provide all of this wonderful information to the application platforms and to the local, maybe iPhones or whatever, and including a great deal of information about what bandwidth was available and what caches were available. And that seems like very valuable information. Why do you think that the network operators would actually be willing to provide that to the Farmville developer? And also, there were some things on the side as to which other people and objects were also nearby, and why do you think those people would be willing to provide their locality to the application?
So think about it this way. So let me go from your second point backwards. So if I'm already checking in at a particular restaurant, I've already given out the information of where I'm located in the topology. What we're adding on top of that, or could add on top of that, is utilization of that path. Am I able to send you real-time video from what I'm doing at this end of the Comcast festival versus your end of the Comcast festival last night? If I know that I can't do that in HD, don't send it in HD. Don't give you a blocky type of transmission. So the goal in this particular case is, if the information's already given out, then you can do something better with it, because we have the information. So the first piece that you asked about was, why would an operator want to give this out to Farmville? An operator would want to give this out so that when, and I'm going to take a different example of Silverlight or Adobe Move, with their control channel over variable bitrate video. Right now the APIs look like you can open up, and sorry, they work over multiple TCP sessions to begin with, and that API looks like, oh, you have a dial from 0 to say 1,000 TCP sessions that could be used for this video. What's the first thing that every programmer does? 1,000 is more than 0, so therefore I'm going to turn this up to 1,000. It's the number one thing that's done. They attempt to amp up all of the aggressiveness that they possibly can of that control channel to deliver the best video. It's exactly what you'd expect them to do. If instead, underneath Silverlight or Move was information about utilization of the network in real time, and instead of having an aggressive control channel, the control channel would in addition go and say, is it even worth my time? Is the bandwidth even available? Should I tune this down for better experience of the multitude of folks looking at this video? You have the potential to do that. So why would an operator want to do that? They would want to do that to, again, deliver the best experience over their network, as well as dampen the aggressive nature of the current algorithms that are out there trying to scavenge bandwidth or scavenge information or derive information. I hope that made sense. How many more questions can I take?
Randy,
Let's just take the rest of them, and then we'll close the lines after this.
Okay, go ahead, Randy.
Randy Bush, Jay. Dave, you get the William Jennings Bryant Award for the silver tongue in making the most complex proposal I've ever heard. To vastly complicate my network to solve a problem that I can throw bandwidth at instead of throwing money to you. So, to answer the first gentleman's question about economics, but the real worry I have, somebody touched on it, the privacy issue, the security issue. This is a complex evolution of something that died about 3 times, used to be called active networking, and those things, and wondering, and they all died on the security vine, and wondering, that seemed to be kind of missing here. The security, privacy, the network neutrality issues are in a sense part of that, etc. And when I don't hear it, I worry that you're going to paint it on afterwards, and we know how well that works with security, instead of seeing it at the base of the architecture. So, William, would you spin the silver tongue on security?
Again, we're going to have wonderful weather here this week in Philadelphia. So the security issue, I don't think I've fundamentally, first of all, obviously I didn't fundamentally address it. There is no doubt about that. Randy and others are correct. I also didn't, I believe, mention anything that isn't already done or isn't already known. In particular, when I take a look at how networks are trying to become aware of application space and the deep packet FUBARs and stateful flow nonsense and all this other stuff that's out there and deployed, the aspect of security and privacy in particular, and I'll focus on that one, is a problem that I'm completely sidestepping. And I'm completely sidestepping because what I'm trying to do is potentially remove all of the deep packet FUBARs, et cetera, and instead, if an application does want to put something on a particular network, they can at least interact with the network at this point. So I don't want to completely silver tongue this, Randy, and basically say I'm either punting or I'm doing something otherwise, but if I can remove the full peeking and poking into all flows and all information that currently is the only way to derive this information from a network point of view and open this up for active communication to go back and forth, I'd actually say it's at least a opt-in proposal versus a what is somebody scavenging about all my flows. Sue,
Yeah.
I'll get
So, Sue Hares, longtime BGP or Huawei. So Dave, when we did Network 2, we were looking at some of this, and you didn't necessarily like this. You poo-pooed it quite a bit while we were doing application-specific networking. When you were routing AD, it didn't exactly like PCE. I know because I work with some of the guys. You proposed some other things. I'm looking on the positive. What's changed your mind? What new revelation have you gotten? Did it come from SDOs? Did it come from customers? What caused you to take a switch from your previous position?
cheekily, I'll say that the bolts in my neck that I had at Cisco are now out, but no, I tease my friends. So anyways, we all learn. Now, if you remember what PCE, and I touched on this a bit, was originally set up to do, and it was a quick and dirty hack of BGP to pass some information around. I'm using the constructs of that technology, or advocating the constructs of that technology, to reinvent soft PVCs between endpoints within an autonomous system. So I'd say that over time we all learn, and we all learn how to use what's available towards hopefully building a better internet. I can't say anything else, Sue. I didn't destroy it. I didn't attempt to take down a number of things, but I certainly wasn't an advocate of what they were being used for originally. Over here.
Brett Watson, New Star. I was surprised that you didn't, I had the same question Randy had about security, and you didn't mention IFMAP, which Juniper participates in the development. Do you see that playing a role in this architecture?
Yeah, absolutely. So if I was to look at what was going on a VPN gateway, an enterprise VPN gateway, these VPN gateways have IFMAP information, and IFMAP is just a generic way to spew lots and lots of information about a particular session in the applications traversing that tunnel to that security gateway. What's interesting in the way I consider this data coming out of that gateway is really telemetry data. It tells me who the subscriber is, it tells me what device they're on, what OS they're running, the capabilities of that device, and the application or service profile that that user has traversing that particular secure tunnel. What's interesting about this is this data is being directly used in enterprises, and we can talk at another talk or even next week at the Open Networking Summit about enterprise and programmable networks. But in this case, let me describe how it's being used. This telemetry data is the difference between me being, let's say I'm a financial trader working for some bank and somebody's occupying that. But let's say I'm working for this particular bank. The fact that I'm here at NANOG on my mobile phone or iPad means that I do not have access to the trading floor. I don't have access to the trading floor based upon, again, the device I'm on, where I'm located, and potentially to the access point. So inside these enterprises, if I'm not on the trading floor itself, I don't have access to that aspect of my virtual desktop, that's those storage pieces or whatever the case might be. IFMAP directly is, again, this information coming out of a gateway system, whether it's a secure tunnel or even subscriber BNG BRAS system, that will give you this data to be able to build a service profile out of it. This, again, is an attempt, or sorry, this I think is another way we can overcome the current lock of radius, diameter, or other ways of constructing a service profile such that an operator can build their own database in conjunction with these protocols or completely separate from those protocols to build a service profile based upon this telemetry information. One sec, Dave. Last question, please.
Richard Barnes, BBN, first time NANOG attendee, but chair of the IETF GeoPriv working group. So since we're constrained on time, I won't ask a question. I'll just say two things. The first is to provide a forward pointer for those in the room. We actually have a presentation that I'm giving later in the week on Wednesday morning on geolocation specifically and some of the work that's been done in the IETF to look at how we can enable geolocation services through the DNS and through some web services and possibly through the WHOIS databases. So we have some technical specifics on that Wednesday, I think at 11:30. The other thing I wanted to mention is, to echo Randy's point and the other commenter's point about security and privacy, and maybe to sound a little bit more hopeful note, because there has been some real thinking about privacy, especially in the context of geolocation. Is some long-going discussions in the IETF, and we actually have a couple of RFCs on this, the most recent being RFC 6280. So if people want to check that out, there's been a little bit of thinking about this, and maybe it can help address some of these questions.
Thank you very much.
Thanks, Dave.